In this video we are going to learn how to solve the Hamming code problem using the shortcut method, right? So here what we are going to do is, what is the given message? The given message bit is 1101, right? So here it is something called as the transmitted code, right? So this is the question identification it is related to the transmitter part, right? So now here in the transmitter part what we have to do is, right, they have given message bit value. What is the message bit value? They have given 1101. So for that what we have to do is, we need to add the extra parity bit value, right? Now what is the formula to find out the parity bit value? The formula to find out the how many number of parity bits are required is, the formula is 2 power p greater than or equal to m plus p plus 1, right? So by using of trial and error method, we are going to identify how many number of parity bits are required, right? So just for example, suppose if you apply 1, right? So let it be p equal to 1, then 2 power 1 greater than or equal to, always m value equal to constant, right? So 4 plus, what is the p value we have considered? 1 plus 1. So this condition is not satisfied, right? Because 2 is not greater than 6, right? Now if you take 3 as a p value, 2 power 3 greater than or equal to 4 plus 3 plus 1. So this condition is satisfied. So number of parity bits are required is the 8. So in this place we need to add the number of parity bits 3, right? So now what we are trying to do is, by using the simple method, how we are going to find out the answer, that we are going to learn in this today's class, right? So for example, see what is the length of the total transmitter part. It is a combination of the message bit is nothing but the 4 bit. After identifying parity bits, we have the 3 parity bits. So total length of the transmitter part should be 7 bit value, right? So for that what I am going to do is, just I am writing the number from 1 2 3 4 5 6 7. Why am I mention here 7 bit? Means the length of the message, that is our total transmitted code would equal to 4 plus 3. So that's why I'm writing the number from 1 to 7, right? So once it is done, right, we need to identify the location of the message bit as well as the parity bit, right? We cannot able to find out the location of the message bit by default, right? So but we can able to find out the parity bit value, right? So in which location we have to find out the parity bit is, the location is r power 0, r power 1, r power 2, r power 3 something. It means that for binary value r equal to 2, right, that means location should be 1 2 4 8 16 something. So as per our question, we have only 3 parity bits, right? So just we required only the locations are the first location, second location and fourth location, right? So just I am writing the location. So here it should be p1 value, here it should be p2 value, then fourth location here it should be p3 value, right? So now if it is not parity bit, then what about this one remaining all the message bit, right? So this is m1, this is right, m2, then one more is the m3, then one more is the m4, right? So now one more thing, after doing all these things, as per the given question, they have already mentioned what is the message bit value, right? So what is the message bit value they have mentioned? It means that, right, so 1101 means this is the message bit value they have given, 1101, right? Now what is the thing here we need to identify in the transmitter part? Means as of now we have identified we required 3 parity bits, but we don't know what is the value of the parity bits, right? It may be 1 or 0, that we need to find out. So initially these values are the unknown values, so just I'm representing with the cross mark. So what I mean is that finally I need to find out what is the p1 value, what is the p2 value, and what is the finally p3 value, that we need to find out, right? So now how to find out p1 p2 p3? We will try to apply the simple procedure, right? So now if you see this, from where we have the p1, right? So what is the location of p1 here? The location of the p1 is something here, right? So first location we have the p1, right? So what is the procedure here? Means, right, we are starting from the, we are starting from the p1. So which location it is? It is location in the first location. So it means that we are starting from this direction, right? So it means that if we are taking the first position, then we need to leave the second position, then we need to write to the third position, then we need to leave the fourth one, then we need to fifth one. So it means that if you are starting from the first position, you write the first position value, then skip the next value, then write the next value, skip the next value, write the next value, something like that. Why only we need to skip the 1 bit? Means we started from the first location. First location means 1 bit to be considered, 1 bit to be skipped, right? So how we can write for p1 is the first location, means you consider the first location value, then second location value skip it, because we need to skip the 1 value, right? So 2 is skip, 3 we need to write, 4 is skip, 5 we need to write, 6 is skip, 7 we need to write. right? So now see that as per the given question we have these values, right? This value is nothing but the 135 position, 537 position, right? So what is the location of first bit value? This value, right? What is that value? As of now, this value is the unknown value. Now what is the value of third location? Third location, this value is the 1, right? Right. So what is the location of the fifth value? 0. What is the location of seventh value? 1. So as per by default what method we have to use? We need to use the even parity method if they didn't mention anything, right? So even parity means just count the total number of ones. How many total number of ones here we have? 2 ones, right? Because this is unknown value, we need to find out. So count the 2 ones, right? 2 ones means even number, right? So what should be the output according to the even parity? 0, because it is already even number, then we should write the output equal to 0. Simple thing. Now we'll try to find out the P2 value, right? So we'll try to find out the P2 value. So how to find out the P2 value? In which location we have the P2 value? Which location we have the P2 value? We have the second location. Second location means at a time we need to consider the 2 bit. First location means at a time we need to consider the 1 bit. So P2 which is in the second location means at a time we need to consider the 2 bit, then we need to skip the 2 bit, then we need to consider the 2 bit, then we need to skip the 2 bit. Like that we need to consider, right? Why we need to consider 2 bit, then 2 bit skipping means the P2 start from the second position, right? The P2 start from the second position. So it means that we need to consider the value like that, right? So at a time means we need to consider the value 2 bit means we need to consider the 2, 3, right? So to find out we need to consider 2, 3. Next what we have to do for 4 and 5, we need to skip means if we started from the second location, 2 need to be considered, 2 bits to be skipped, right? So next to be considered, what are they? 6, 7, right? So 2, 3, then 4, 5 skip, 6, 7 consider, 8, 9 skip, something like this. Now what is the location of the value in 2, 3, 6, 7 position, right? So what is the location of value in second location? This is unknown value, right? So just write down cross mark. Now what is the location of the third value? So this is the third value, right? What is it? Bit value 1. Now come to sixth position, what is that value? The value is the 1. Come to seventh position, what is that value? 1. So just count the total number of ones in this sequence. Even number or odd number? Odd number. Odd number means we need to add the 1, right? And now we obtain the P1 equal to 0, P2 equal to 1. Now we need to find out the P3, right? So if you observe P3, where it is starting from? The P3 is starting from which location? It is starting from the fourth location. Fourth location means at a time how many bits we need to consider? 4 bits at a time. Remember, second position means second bit at a time. 2 bits need to be considered, 2 should be skipped, 2 need to be considered, 2 should be skipped. If P3 is present in the fourth location means at a time we need to consider the 4 bit value, right? We need to consider the at a time 4 bit value, right? So see that here we are considering the fourth location means we are considering the 4 bit value. What is that value? 4, 5, 6, 7. Next what we have to skip? We need to skip 8, 9, 10, 11. Then again we need to write 12, 13, 14 something. But in this equation we have only 7. So this is not required. Fourth location means we need to consider the 4 bit at a time, right? Then 4 skip, 4 need to be considered. Simple thing, right? Now what is the value of fourth location? This is the unknown value, right? Just write down unknown value. Fifth location value, this is 0. Sixth location value 1. Seventh location value 1, right? Now just count the total number of ones, even number or odd number? Even number, right? So even number means what should be the answer? 0, right? So just applying this position, right? First position means if you are starting from the P1 which is in the first position means second should be skipped, then means we need to write the 3, 4 should be skipped, 5 we have to write, 6 should be skipped, 7 should be right. So if we are starting from the P2 which location we have? Second location. So second location means at a time we need to consider the 2 bit, then 4, 5 should be skipped, then 6, 7 we need to consider. If you are P3, just check that P3, it doesn't means that it is from the third location. Where P3 we have? P3 is in the fourth bit location. At a time we need to consider the 4 bit at a time, then 4 bit skip, 4 bit consider. So if you apply this procedure, you can able to find out the solution for any Hamming problem in the transmitter part. If you try to apply the same theory for the receiver also, you will be finding the same answer. It means you can able to solve this problem within 1 minute, right? So here in transmitter section you are going to find out the how many parity bits, then you are going to find out the where to place the parity bit, then you are going to find out the parity bit value. In case of it, if it is receiver question, just you don't need to find out the parity bit value once again, just to calculate whether it is error or error free, right? Thank you.